US Physics Olympiad, year 2011, USAPHO, Semifinal exam. Problem number A2. Solution for this problem you can find below this video in the reference of the description. A thin uniform rod of length L and mass M equal 0.258 kilograms is suspended from a point a distance r away from its center of mass. When the end of the rod is displaced slightly and released, it executes a simple harmonic oscillation. The period t of the oscillation is timed using an electronic timer. The following data is recorded for the period as a function of r. What is the local value of g? Do not assume it is the canonical value of 9.8 meters per second square. What is the length L of the rod? No estimation of error in either value is required. The moment of inertia of a rod about its center of mass is 1/12 mL square. You must show your work to obtain full credit. If you use graphical techniques, then you must plot the graph. If you use linear regression techniques, then you must show all of the formula and the associated working used to obtain your results. These are experimental data here. Solution. We can use a formula for a period of a physical pendulum. This one. Period equal to pi multiplied by square root from moment of inertia divided by mgr. Moment of inertia for physical pendulum using parallel axis theorem equal this expression. Now we can insert this expression to this formula and find expression for the period. Now look at this formula. Here we have to find what is a g and what is L. And we have experimental data for period t and distance r. So we can linearize this formula in form of this expression. If we look carefully to this formula, we have data for r square, we have data for this coefficient to g, and we can represent this formula as a graph like this. Here we have y must be equal r square, x equal this expression, and b equal this expression. So now we can draw the graph for this formula. First we can do table. Using this experimental data we can fill this table with the coefficients, and after that draw the graph. Graph will look like this, and from this graph we can find what is the slope of this straight line and what is the coefficient b which crossing this line. So finally we can find that this g equal 9.179 meters per second square and L equal 1.47 meters. So that's the result.